Hello everyone. Today we are going to discuss about the internetworks. Internetworks or simply internet. It is formed when two or more networks, either LAN, MAN or WAN, are interconnected by a bridge and or routers. Routers connect two or more logically separated networks. The main function of router is to route the data packets along with the correct path from the source machine to the destination machine. So what is the function of router? It is going to transfer or route the data packets along with the correct path. So it is going to decide the correct path and it is going to transfer that information from the source machine to the destination machine. Following two figures shows the configuration of internet. In figure A, two LANs and one point-to-point WAN are formed in an internet, while in figure B, several LANs and WANs are connected. So as we can see this is the West Coast office in which we can see that there is a LAN connection. In LAN, we know that there are too many devices or n number of devices are connected to each other, and that LAN area is covered with a small area of portion. The output of this LAN is connected to the router. This is R1 router. After that, there is a point-to-point WAN. So this is a single point-to-point connection between R1 and R2. So R1 is your router 1 and R2 is the router 2. The connection of router 2 is connected to the East Coast office. So again, there is a LAN connection in which there are multiple devices connected to the single PC. After that, this is nothing but a point-to-point connection. It simply connects two devices which are two locations which are at different positions, West Coast and East Coast. These are the two offices basically, and they are connecting the data. They are sharing the data which are transferable in the connected devices through the router package. So this is nothing but a point-to-point connection in which we have only a single communication link between two devices. In second figure, as we can see here, there are several LANs and WANs connected. To observe that, we can see that there is a modem, which is modulator and demodulator circuit. After that, the output of modem is connected to the point-to-point WAN. The output of modem is connected to the point-to-point WAN, and again it is connected to the another modem because this modem is used for the resident purpose. For an example, this modem is used for a switched WAN. So switched WAN is what? There are multiple switches and they are connected with the number of devices. After that, the output of this switched WAN is connected to the router circuit. This router is again connected with the second router with the point-to-point WAN connection. After that, the output of this switch WAN is again connected to the second router. As we can see, the output of switch WAN is connected to the two different routers. This is router 1, this is router 2 for an example. These two routers are connected with each other with the point-to-point WAN connection. Again, these two routers are connected to each other with the point-to-point WAN connection. So we already know what is point-to-point communication. In last lecture, we have studied about the point-to-point WAN connection. After that, the output of the router is again is connected to the LAN connection. LAN is what? Simply a local area network which is restricted to the small portion of land. Again, here also this output of router is connected to the LAN. So in LAN, we have multiple devices which are connected to the single switch. So this is nothing but a several LAN and WANs connection. So we can simply say that it is an internetwork. Internetwork is what? It is a connection between multiple devices. After that, there is a concept of switching. An internet is a switched network in which a switch forward data from one network to the another network when required. So whenever there is a requirement, a switch is the device which forwards the data from one network to the another network. The switching device which provides communication is called as node. So whatever is the switching device which provides communication, that is called as a node. Node is what? A connection between two devices or 2 points. So at a point where we are going to connect two devices, that particular point is called as a node. The end device is called as a station. So whatever is your end device, either that is a destination or that is a source, that is called as a station. Station may be a computer, mobile, or any other communicating device. So no matter what is the end device, that might be your computer, mobile phone, or any other communicating device. It's just that it is just required that we want a device which will be able to communicate. In switching network, the switching nodes are mainly concerned with the providing a switching facility that will move the data from node to node until the destination is reached. So if I'm transferring data from one position and there are several nodes in between, and at the last I'm having my destination point. So until and unless my data reaches to the destination, that data will travel from node to node. So there will not be loss of data at all. Figure 4.6 shows the simple switching network. Signals entering in the network from the stations are routed to the destination by the switching from node to node. So we are going to see how signals enter into the system and how it is traveled from node to node and how it reaches to the destination source. For an example, information from the station B, as we can see the diagram. In the diagram, just consider information from station B is sent to destination D. So this is consider this is the source, computer A, computer B, computer C, and computer D. We can just simply named it. So as what is written here, for an example, information from the station B is sent to the station D. So what do we want to do? We have to send information from this source or this computer B to the computer D. Then first information is sent to the node 1. It may be routed via node 2, 3 or via nodes 4, 5, 3 to the destination. So what will happen here? The computer B wants to send the information. So what it will do? It will send that information and the source and the code of the destination folder or destination computer. So B computer will send the required data along with the path of the destination. So it will send the data as well as address of D. So what will happen? This switch will automatically transfer that data to the computer D, because switch have the address of computer D. Switch is not having address of A and C. That is why it will not send the data to computer A and computer C. It have address of D. That is why it will send entire data to the computer D only. So this is how switch works. So switch is called as a smart switch. Why? Because it is able to understand the destination source as well as the information. There are two switching technologies used to achieve this. So there are again two basic technologies which are used to achieve this: circuit switching and packet switching. Okay, in circuit switching there is a dedicated communication path between two stations. So if we are opting for the circuit switching, in that there is a dedicated communication path between two stations. The switch can only be make it achieve active or inactive. So basically, there are two devices only, and in two devices there is a communication link, and in between there is a switch is placed. If we want to activate the communication, the switch will get turned on, and if we want to inactivate the communication, the switch will remain off. This is how circuit switching is work. In case of packet switching, data are transmitted in the form of blocks, and that is called as a packet. So we are going to see how the data is going to transmitted in the form of blocks and how the transmission is happened. After that, we need to study some network topologies, how the network is formed between number of devices. Network topology refers to the way in which two devices can connected. So how many number of ways are there in which we can communicate or we can connect multiple devices? Various network topologies are explained below. So we are going to study each and every in detail. First topology is your point-to-point topology. So in point-to-point topology, connection provides a dedicated link between two devices. What we are going to have here in point-to-point communication, there is a dedicated link between two devices. So this is my device 1, this is my device 2. In between them, there is a dedicated link. Okay, the entire link capacity is reserved for a transmission. This link is totally reserved for the transmission. The dedicated link may be an actual length of wire or cable or a microwave or a satellite link. This link should not like the link can be any. It is a wired connection or it is a wireless communication. If it is a wired, we can have any kind of wire, fiber optical cable or coaxial cable. There may be a wire, microwave or satellite link also. This is a physical connection, that is a physical or wired connection. And in case of the second diagram, the below diagram, there is a RF link. So communication is happening with the help of wireless communication. Okay, so in case of point to point communication, we are actually going to connect two devices with the help of wired or wireless transmission medium. The second one is the star topology. In case of star topology has a central controller called as a hub. So we are going to have a center computer or a center controller which is called as a hub. All the devices are connected to the hub using the dedicated point-to-point link. So we are going to study how this works. If one device wants to send the data to the another, it sends the data to the hub through which the data goes to the other devices. So here we are not going to have a direct transmission of data. What if we want to send the data? What we need to do? We have to send that information to the hub, and hub will transmit that information to the destination folder or destination computer. The star topology does not allow a direct traffic between devices. So we are not able to access the other device directly. In case of star topology, in star topology, each device needs only one link and one IO port to connect it to the number of devices. So the advantages, you may say, of the star topology is to it needs only one link and one IO port, that is input output port, to connect to the any number of devices. So with the help of only one link and one IO port, I can access number of devices which are in that, which are connected in a network. So what are the basic advantages by using the star topology is that it is in the star topology, the lace cabling is required. So whatever the hardware or whatever the communication medium we are going to use, the lace cabling is required in case of star topology, which reduces ultimately the cost of entire system. Second, it is easy to install and reconfigure. So installation of the star topology is very much easy, and the reconfiguration is also very much easiest. Third advantage of the star topology is the fault identification and fault isolation is also very easy. If there is a error which is occurred in a star topology, the identification of the fault is very much easy. If one link fails, only that link is affected, other links remain active. If there is a entire network, and in entire network, if one of the link gets failed due to any reason, the another remaining network is not get affected because of the failure of one link. The remaining network is still remain active. So this is the major advantage we can say which provides with the star topology. But there are some advantages also by using the star topology. The whole technology is dependent on a single point hub. Okay, as we have seen that there is a central computer or central controller which is called as a hub. If that controller gets down, or if there is any problem with that controller, the whole or entire system is going to be dead. This is why the star topology is very critical to handle, if we can say that. After star topology, this is the diagram of star topology. This is a central controller, and that is called as a hub. There are a number of devices which are connected to the hub. Now, if I want to send the information from computer 1 to computer 2, I need to send that information to the hub, and hub will transmit that information to the second computer. Likewise, so there is no direct communication between the devices which are connected in a network. Ring topology is the next topic. In case of ring topology, each device has a dedicated point-to-point connection with only two devices at either side. So we are going to have a dedicated point-to-point connection with the only two devices on either sides. Single travel in one direction from a device to device until it reaches to the destination. So if I want to send the information from this computer, as we can see the diagram, this is a ring topology in which all the devices are connected in a ring format, right? So if I want to transmit information from this computer to this computer, okay, so what will I do? This information will go to this repeater. This will transmit that information to the computer too, but this is not the destination address. Okay, so that information will get forwarded to the next computer. Again, the destination address is not going to match with this computer's address. That is why this computer will not be able to access the data. Again, this information, whatever the data I have sent, that will transmit it to the next computer. The destination address is matched with this computer, and that is how this computer will able to access the data which is on the transmission line. So this is how ring topology operates. Each device in a ring incorporates a repeater. What is a repeater? It is if there is a large distance between the two computers, the signal gets weakened, and to increase the strength of the signal, we are having a repeater. If the signal received is intended for the other device, the repeater passes it to the next. So if we are sending the information to from this computer to this computer, these two repeaters will not allow to pass the data to these computers. Why? Because the destination address is not going to match with these computers. That is why the repeater will pass that information further. Again, this repeater is also check for the IP address of this device, and if it is not matching, it will pass that information to the next computer. This is how ring topology works. There are some advantages of the ring topologies, which are, since each device is linked only to its two neighbors, the ring network is easy to install or reconfigure. So as we can see in the diagram, each device is connected to the only two of its neighbor. Okay, so this one number PC is connected to the second PC and third PC. There is no direct communication between this PC and this PC. So this is how installation is very easy in case of ring topology, and fault isolation is easy since the fault device can be bypassed by altering the connections. If there is one of the system in a ring topology gets failed, what will happen? The device can bypass by altering the connections only. Again, there are some disadvantages of the ring topology, which are limitations on a maximum ring length and the number of devices connected. So there is a limitation on which how many number of devices we can connect in a single ring network, and unidirectional traffic lowers the transmission rate. So unidirectional data flow is one of the major disadvantage of this. What is unidirectional flow? We'll see this. If I want to send the information from this computer A to this computer 3, consider this is a computer 3. If I want to send the information from this to this computer, now if the flow is unidirectional, that is flow is in this direction, so the information will pass through one, two, three computers, and then it will reach to the destination source. As there is the smallest way available that information can pass through only single computer, and then it will reach to the destination folder. But the limitation is that the unidirectional flow. Unidirectional is what? In a single direction only data will flow. Okay, so data will flow in a single direction only. Data will not flow in this direction. Why? Because the unidirectional is the major thing which is providing a disadvantage to the ring topology, right? So it will lowers the data rate. Why? Because it will require a large time to reach the data from this position to this to this to this to the final destination folder. Okay, data needs to travel this long path to reach to the destination. So this is how unidirectional flow affects the transmission rate. After ring topology, we have burst topology, in which we have like overcome few of the disadvantages of the ring topology. Here nodes are connected to the bus cable by drop line and taps. So what we are having here, the nodes are connected to each other with the drop lines and the tap. Thus the long cable links all the devices in a network, which acts as a backbone. So as we can see the diagram, this is the cable end, this is the terminator. So this is where the cable, like you can say the cable starts from here and cable ends at here. So these are the extreme ends of the cable. Cable is what? It is a transmission medium again. This is connected to the node 1, node 2, node 3, node 4. Okay, so these are the nodes which we are having, and these all the nodes are connected to this cable with the help of the tap and drop links. So this is the drop link and this is a tap. Okay, so this entire cable is works as a backbone of the entire system. Now, how data will transfer in this? If I want to transmit the data from node 0 to node 2, what will happen? I will transfer the data through this drop link to the top, and the data will transmitted all over the link, okay, all over the cable. So if I wanted to transmit it to the node 2, the data will get connected with this tap and drop link to the node 2. Now how data will get connected to the node 2 only? This tap is smart enough to identify the IP address which is given by this node 0. The node 0 will give the destination folder, right? And the destination folder is node 2. So automatically data will get connected, or data will be accessible to node 2 only, and it will not be accessible to node 1 and node 3. Why? Because the destination is not matching. After that, there are some advantages, which is bus topology is easy to install. Again, there is a single communication link, and we have to add number of devices with the help of tap and drop link. This is just a simplest installation, you can always say. It requires a less cabling other than a star and mesh. So how much is the cable we required here? This long cable is just required here. No other cabling is required in case of burst topology. Disadvantages of the ring topology, bus topology are there is a limitation on a number of devices that a bus can support. Okay, so there is again limitation how many number of devices we can connect to this link. Okay, this is the major advantage of the bus topology. This is because as the signal travels along the backbone, it becomes weaker. So signal there is a huge number of devices. Suppose there are number of devices are connected in this cable. Now what will happen, the backbone will become weak. Why? Because the data is continuously traveling through this backbone or this cable. That is why it will become weaker. Signal reflection or loss of the signal at the taps further degrade the signal quality. The signal reflection or the loss of signal at the taps, it will degrade the quality of the signal. It is difficult to identify and isolate faults. A fault or a break in the bus cable stops all the transmission. So if there is a fault or a break in the bus cable, it will stop all the transmission. There will not be any transmission if it is found there is some fault or a break in the bus cable. Okay, so this is all about the bus topology. Next one is the mesh topology. Again, in mesh topology, every device has a dedicated point-to-point link to other devices. If there are n nodes, we then in that case we need n into n minus 1 divided by 2 duplex mode link. This allows direct communication between any two devices. So this is the major advantage which is provided by the mesh topology. We'll see how many other advantages we have with the mesh topology. The topology provides the highest degree of the fault tolerance. Whatever is the fault tolerance capability of the system is very highest as compared to other topologies. Traffic problems are eliminated because there is a dedicated link between any two devices. If we are having n number of devices, the traffic is less. Why? Because there is a dedicated link between two devices. If I want to transfer the data from one device to second, there will not be any traffic because that link between two devices is specifically designed for those two devices only. It is robust as the network does not crash even if the one link becomes unstable. So, as I told you earlier, there is a dedicated link between two devices, and if that link gets fail, the entire network is not going to be disturbed. That the entire network is going to remain live as it was. The privacy is more. So, the privacy which we need in the communication or transmission of data, that is very high in case of mesh topology. Since the data is sent through the dedicated link, only the intended recipient receives it. So no other device will be able to access the data which is sent on a transmission link other than a destination folder. Reliability and security is more, so we can rely on the system, and the security is also high in case of mesh topology. Again, there are some disadvantages. The main problem is the amount of cabling required to interconnect the device, and the number of IO ports needed to the each device. So first of all, cabling is very much or the very most very much like it is the most biggest disadvantage of the mesh topology. Why? Because as you can see, we have 1 2 3 4 5 computers, right? 5 computers in a system, and each one of them is connected to each other. So these two devices are connected to each other with this link, these two with this link, again this and this. So this computer required at least 4 IO ports and 4 cables, right? So this will require 4 IO ports and 4 cables. Again, this will require 1 2 3 and 4. So again, this will require 4 IO ports. Each and every device will require at least 4 IO ports. Okay, to communicate with the each and every device connected in a mesh topology. So number of IO ports requirement is very high in case of mesh topology, and number of cable requirement is also large. Expensive because of the large number of hardware requirement. So it is very expensive. Why? Because the large number of hardware requirement is there. As we can see, there are number of links or number of cables are connected within a number of devices, and to install that, obviously the installation cost or the purchase cost of the each and every material which is hardware, that is going to be very large, and ultimately the entire cost of the system will get increases. So as we can see here, there are 5 systems in a network. The number of devices is equal to 5. That is how many links we are going to require. N into n minus 1 divided by 2. That is 5 into 5 minus 1 divided by 2. The total 10 number of cables we require to interconnect all the computers in a system. So this is how mesh topology operates. After that, a tree topology, which is quite widely used. In this topology, only hub connects directly to the tree bus, and each hub functions as a root of a tree device. The disadvantage of this topology is that it allows easy expansion of network. The advantage of this topology is that it allows easy expansion of the network. So we can simply expand our network by adding one more hub here. If I add one hub here, I can connect again number of devices to that hub. It is also called as a starred wire tree topology. So it is a star. So why? Because why it is called as a star wired tree topology? There is a star connection. Whatever the things which we used in a star connection, all that connection is there is present in the tree topology. Wired connection is there, and this is a tree-like structure. That is why it is called as a tree topology. Main drawback of this topology is dependency on the central hub. Failure of central hub disturbs the whole transmission medium. So as we already know, if there is a single hub which operates entire system, it will get disturbed, right? If the hub is get damaged or it may get disconnected, in that case, what will happen? The entire system will get disconnected. So this is the major drawback of the tree topology. After that, there is a another topology which is daisy chain. The daisy chain network is one of the simplest network topology in which one station is connected to the next without any interconnecting devices. The daisy chain network is one of the simplest network we can say, and it will provide the topology in which one station is connected to the next without intervening the devices. Thus, the data is sent from one station to another until it reaches to the destination. The advantages of daisy chain technology are easy to uh, it is very easy to add up a new devices in a network. So as we have seen that by simply adding one more hub, we can connect number of devices to the system. No use of extra cables. So it is not requireable to use extra cables. Data transmission is also faster and easier, and the construction is cheaper. So as there is no extra cables are required, no extra hardware is required, the cost of the entire system is low. But there are some disadvantages. If number of stations in a network are increased, it can slow down the whole network. Daisy chain network topology can be bus or ring type as explained earlier. So if I increases the number of hubs, so it will indirectly increases number of devices, and if there is a like huge number of devices in a single network, it will slow down the speed of entire system. So this is what is the advantage of the tree topology. After that, we are having a hybrid topology. When two different basic network topologies are connected, it is referred as a hybrid topology. Hybrid is what mixing of two different things. Here, hybrid topologies, mixing of two different topologies. For an example, a combination of star and mesh topology is known as a hybrid topology. The overall features of the resulting interconnection inherits the features of two different network topologies. This gives the overall benefit to the networking system. After that, the advantages of hybrid topology due to the flexibility and ease of use. So it is very easy to use and the flexibility is also high. In case of hybrid network, it can be set up at any place. So there is no location restriction on this kind of hybrid topology. Basic topology have own advantages and disadvantages. We have already seen that there are some advantages and disadvantages to the each and every topology. Selection of appropriate basic topology while forming a hybrid network can increase overall network efficiency. So basically, if we select the topology as per the requirement, then we will be able to increase the overall networking efficiency. One can select the backbone network will have a hub or a switch and another network segment. So we can select the backbone that may be either hub or switch and another network segment. So it is we are free to select the backbone as well as entire network. Due to its hybrid structure, the overall features of the each topology are equally distributed in the chain of network. So the network topology is hybrid. So whatever the overall features we are having for the each topology, those are equally distributed to the chain of network. That offers the easiest way to detect the errors and also help in the doing the troubleshooting. So if there is a problem, or if there is a defect, or if there is any troubleshooting is required in the entire system, then it will give us the easiest way. This topology is more flexible, reliable, effective, as well as scalable than other networking topologies. So flexibility is high as we are selecting the hybrid combination of two different technologies. It is reliable that we are free to access, or we are free to choose our destination as well as entire network system, and it is scalable other than other networking topologies. Only drawback of this topology is to difficulty in managing and higher cost. So managing is difficult as we are selecting our hub or switch or a entire network. To select that, it is very difficult to manage, and the higher cost. So as we are merging two different technologies, the cost is ultimately going to increase. Still, due to its robust and effective features, this topology has gained a lot of popularity among all the topologies. This is one of the most popular technology or topology, you may say. Why? Because it offers a robust communication or transmission, and it gives the effective features to this topology. So this is how hybrid technology or hybrid topology works. This is my ring technology, in which there are few devices are connected in a ring format. Output of this ring format, or one of the PC from that ring format, is connected to the hub. Right now, this hub will be able to access information from each and every device from this ring technology. Right after that, there is a star topology. In star topology, we have a central computer, and that central computer is connected to the another 4 computers. So this is the star topology. Now the central computer is connected to the hub. Now here, this hub can be access the data from any of these 5 computers. So ultimately, what is going to happen if this PC from the ring topology wants to access the data from the PC, which is from star topology, it can access easily. How? This data is accessible to hub, and this data is also accessible to hub. The computer will pass a request that I want to access the data from this computer. Hub will connect to this computer, and this PC will easily able to access the data from a computer which is connected in a star topology. So this is how hybrid technology or hybrid topology operates. For today's lecture, we'll stop here. We'll see the remaining part in the next lecture.